Okay, so we're now going to analyze the data that we have collected. So here's DKG data for a couple minutes of resting subject data. And what we're going to do is we're going to just alter some of the settings here to get us information that we want. So I'm going to start off. You'll notice there's different rows here. Our EKG row, our heart rate row, which is calculating heart rate every beat here. We have our HRV low power, HRV high power, and then the ratio of those two. So we're going to make some adjustments here, and I'm going to go to my HRV low power. I'm going to click on that, and I'm going to click on Setup. And you'll notice a screen will appear here. And what this is going to do, this is going to allow us to alter the tolerance and threshold of my data. Really what I need to do is get these two blue lines to encompass all the R waves, but no other data. I don't want P waves in here, I don't want artifact in here, or T waves. And hopefully, if your EKG is clean, if you don't have really large T waves, this should not be an issue. And so you'll notice here, I have this set at about 64 and 7 on threshold and tolerance. That seems to work for the data I have here. I'm going to click on Compensate for Missing Beats, and I'm going to hit OK. Now, I'm going to do the same thing for my high power, setup, and I'm going to try to use around those same numbers if I can, or at least pretty close to that. And again, this is the same EKG data, so I should be able to do that. We're going to go to Compensate for Missing Beats, and again, we will do the same thing. Now, you'll notice these two rows changed a bit, and if I go to my button up here to auto scale all channels, you'll note that the HRV low power and high power numbers have changed. Because we've altered the settings here that they're reading. And we also have an alteration in the ratio as well. We're going to get that actual data here in a second. So one way we can measure heart rate variability is through HRV frequency in the low power and high power domains. Another way we can do it is through what's called the SDRRI, which is the standard deviation of RR intervals. Now in order to do that, we're going to need to add another row here of data. So we're going to go to our EKG row, we're going to go to Function, we're going to go to Periodic, and then we're going to go to Period. And once we do that, you'll notice on the bottom of our data, a new row is going to appear. And when I do this, a new window is going to appear, very similar actually to what we have seen previously. Now, because of the way I set this data up, this looks a little bit different. It's not as zoomed in, but it's the same idea. And in fact, we can actually probably use the same frequency numbers if we'd like. That actually should get us very similar data. But again, I can alter these thresholds and frequencies as I see fit to encompass those R waves. Once I feel comfortable with what I have, I'm going to compensate for missing beats. I'm going to click that button, and then I'll hit OK. Now what I've done is I've now created a row that's calculating the time between every R wave, the RR intervals. And you'll notice these change slightly as we go from beat to beat. Okay, so now we can begin to get some data. And so we're going to actually now go up to the top of the screen to our analysis tool. And once we do that, a new screen is going to appear. Now, it's a new screen, but it's actually the same data. The only thing different is it now has added some functions. And so inherently what this will do is add what's called a mean function. And so if you notice on the screen here, there's two red lines, one to the left and one to the right. And what's now happening is the mean function, which is just an average, between those red lines, this function is giving us a mean value of the data between those red lines. So for heart rate, 55.9 beats per minute. In the heart rate in the low frequency domain, 81,219.04 milliseconds squared. We can see the value here in the HRV high frequency domain, the ratio. And it's also giving us here in our bottom channel the SDRRI, the mean actually, the mean of the RR intervals, which is 1.055 seconds. Right? So we already have the mean frequency in the low, high domains and the ratio of the two values. So we can document those. And again, we can move these lines to be over a specific amount of data, a specific window of data that we want. If we think there's some artifact in some of the EKG, or we want to not include it in our analysis, we can move these red lines to encompass data that we want. Now, what's really important is we do want to make sure we have a sizable amount of data. We don't want to just have 6 or 7 heartbeats, because it's just not enough of a sample. So we want a good amount of data. Now, we're now going to add another function, because although we have found the mean value of the heart rate variability in the low and high frequency domains, when it comes to the RR intervals, we actually don't want the mean, we want the standard deviation of that. So we're going to go to add function, we're going to go to general, and we're going to go to standard deviation. And you'll notice as we scroll down here, we have a deviation of 0.145, or we can convert that to milliseconds pretty easily. So that is our SDRRI in milliseconds. And obviously there's a sizable amount there. Okay, so that's how we can calculate our HRV in both the time domain, SDRRI, and the frequency domain that we have here. I hope that helps, and we'll see you in the next video.